Yes, good morning, my dear friends, and welcome to physics online classes. Look here, students, in the previous class, we are discussing about the special type of diodes, and in that special type of diodes, you have completed the two important special type of diodes. That is about your photodiode and also completed about the light emitting diode. And today you go for another small thing is remaining, that is about solar cell. You go for the solar cell, and finally you go for the logic gates. It means in the today's class you can complete the topic. Only small thing is remaining, that is about solar cell and about the logic gates. And as usual, before starting the today's class, we'll go for what you studied in the last class in 5-10 minutes to discuss about what you discussed in the last class. Look here, now today we are going for the lecture number 11. We are going for the lecture number 11. And look here, you are the last class you was read about the photodiode. Look here, as you know already, it is the photodiode, it is an PN junction diode, and important thing, it works on the principle of photovoltaic effect. It working on the principle of photovoltaic effect. Or I said in last class about it also, but as the photodiode is working on the principle of photovoltaic effect, or it also called as inner photoelectric effect. The working principle of photodiode, it is nothing but the inner photoelectric effect. And as usual, in the photodiode, it works in the reverse bias. And what is the photodiode? Actually, in the photodiode, the light energy is converting to the electrical energy. The important thing in the photodiode, the light energy is converting to the electrical energy. That is about the photodiode. And as usual, as you know already, a photodiode, it is basically an PN junction diode. It is basically an PN junction diode. And as you know already, yes, here you are having an P-type semiconductor and N-type semiconductor, and it is having here, it is having a transparent glass window. It contains a transparent glass window because here, as you know already, you are having a depletion layer, and especially whenever the light falls on your junction through that glass window, transparent window, whenever your light falls on, whenever the light falls or incident on the junction or on your depletion layer, because of this light having energy, that should be more than the energy gap. As you are using the energy h nu will be more than the Eg. The incident light, that energy should be more than the Eg. Then only we can break the covalent bond, and because high energy of the light waves, the photon of energy, high energy of light wave, that what happens, we can break the covalent bond, and the electron hole generates in pairs. Because of light energy, they will break the covalent bond, electron hole come in pairs. And because of high electric field here, no doubt here in the depletion area, in the electrons and also electron holes are created here. This created electron hole because of this electric field. As you know, here we are in electric field. The electric field is about like that. This is the electric field. Because of the electric field, what happens? The holes, they move towards the p side, electron move towards the n side. This moving of electron will move towards the and also if you apply the reverse bias, as you know your photodiode conduction the reverse bias, and if you apply the reverse bias, as you know already, because of the light falling here, incidenting light here, you can generate the electron holes, pairs are generated, and because of electric field here, these holes they move towards the p side, electron they move towards the n side. This moving of holes and electron will give the current. That current is called the photocurrent. Why is it called photocurrent? The current is because of the light incidenting on your p-n junction. The light incidenting on the p-n junction. The important thing, you have to apply the energy, light energy that should be more than the energy gap. As you know, energy gap as for silicon is 1.1, for germanium 0.7. You have to apply the energy that should be more than the energy gap. Then we can generate the electron holes. They will be generated, and actually they want to recombine, but because of high electric field or because of electric field, the hole they move towards the p side, electron they move towards the n side. They will have the current. That current is called the photocurrent. This is about in brief about your photodiode. Important thing in the photodiode, the photocurrent that depends upon the intensity of light falling on this. How much the intensity of falling on the junction will get the more current. And what is dark current? If the light is not incidenting here, we are having very small current. That current is called dark current. If the light is not falling on the junction, in that time we are having very small current. That current is called dark current. This is about in brief about the phototype. When we go first about the LED. This is called light emitting diode. We already discussed in the last class. It is called LED, light emitting diode. Important thing, it conducts in the forward bias. It is a heavily doped p-n junction diode. And important thing, it also conducts in the forward bias. And important thing, it is a reverse process of photodiode. It conducts in forward bias, and also here the light energy converting to the electric energy. It emits the light, it produces the light whenever it forward bias. It means it is a totally opposite process of photodiode. LED, it conducts in forward bias. The important thing in the LED, it emits the light, it produces the light when it is in forward bias. It means the LED nothing but the light energy converting to the electric energy. In the LED, the light energy converting to the electric energy. This is about the LED, and as we know already, actually in the LED what happens? It is also known, it is also in p-n junction. It is also in p-n junction. And important thing, here also you are having in depletion layer, and here having in right here. Here also it is having a glass window, transfer glass window, but important thing, it emits the light. And here you can apply if you apply the forward bias, and important thing, here you are not using silicon or germanium, you are not using common silicon or germanium, because we want the HU should be more than the energy gap, and we want you are producing the light that emits the light. When it emits the light, the important thing, the energy gap should be in the range of 1.8 electron volt to the 3 electron volt. It means you are not using the common silicon or germanium. If you use silicon or germanium, what happens? Whenever the electron will recombine, they will give the energy in terms of heat. But if you use like the gallium arsenide, or you can use gallium arsenide, phosphate, like that you are using the compound semiconductors. Now here also electron will recombine, but they will give the different lights. They will give the radiations of the light. They will give the light, they will give the produce the light. Not they will give the heat. Whenever the electron will recombine, what happens? They will give the energy in terms of light. They will give the energy in terms of light. And important thing, You are not using common silicon germanium because their energy gap is very less, that is 1.1 or 0.7. But you are to use the semiconductor, that energy gap should be more than 1.8 electron to the 3 electron volt. Then only if you are using that type of semiconductor, in that semiconductor, whenever the electron will combine, they will use the energy in terms of light. And as usual, as you know, this because of forward bias what happens, the depression layer is decreases, and holes here measured carries, electrons measured carries already. This hole they move towards the N side, electron they move towards the P side. In the same time after, this hole will recombine in the N side, this electron will recombine in the P side, and whenever the electron hole recombine, they will give the energy, that energy in terms of light. This is about in brief about your LED. Why it is called light emitting diode? Because it emits the light, it produces the light, it generates the light. Thing is, whenever the electron hole recombine, keep it in mind, you are not using silicon or germanium, you are using the compound semiconductor. It may be gallium arsenide, gallium arsenide phosphate, and different colors. And you will get red color or blue color, green color, like that you get the light in terms of different colors. That depends upon the wavelength and frequency, and also that depends on which type of material you are using. This is about the importance about your LED. Now to another important about the next class, that is about the solar cell. This is so important, the solar cell. Solar cell. Here no doubt, it is also PN junction diode. It is also an PN junction diode. It is also an PN junction diode. The important thing, it also working on the principle of photovoltaic effect. Photovoltaic effect. Or as I said about your photodiode. It is also similar to photodiode. It also working on the principle of photovoltaic effect or inner photoelectric effect. But important keeping in mind, here you are not applying any biasing. It is similar to photodiode, but here you are not applying any biasing voltage. Here also we can convert. Why it is called solar cell? Here important thing, the solar energy is converting to the electrical energy. The solar energy is converting to the electrical energy. Or actually by the help of the solar energy, by the help of sunlight, by the help of the light given by the sun, the radiation given by the sun, we can use that light in terms of the electrical energy. What is the cell? As you know, cell will be the electrical energy, but by the help of solar energy, you can generate the electrical energy, or you can generate the EMF, electromotive force. You can generate the electromotive force by the help of solar cell. It is a PN junction diode, no doubt. It working on the principle of photovoltaic effect, and here it generates EMF. The important thing, without applying any biasing voltage, only the sunlight incident on your junction. In that time, what happens? They will give the electrical energy in terms of EMF. You can, as you know, cell nothing but they will give the electrical energy. That electrical energy given by the help of solar cell. On solar cell, nothing but PN junction diode. We'll go further. This is about in brief introduction to the solar cell. No doubt, solar cell is a PN junction and it generates the EMF. It is working on the principle of photovoltaic effect or inner photovoltaic effect. The important thing, you are not applying any biasing. We are not applying any biasing. And the important thing, how the construction of it, how to construct the solar cell. Here, actually, you take a small P layer. You take a P layer, and in this P layer, you take a P layer, and that P layer can take a P layer. In this P layer, we can grow an N-type layer. The important thing, the thickness of the P layer is about 300 micrometer. The thickness of the P layer is about the 300 micrometer. and thickness of the N layer, there is about 0.3 micrometer. It means you are constructing the solar cell by the help of P-type semiconductor and N-type semiconductor, or you can say about P layer or N layer. The thickness of P layer should be 300 micrometer, and N layer that should be 0.3 micrometer. And you ask the question, why you have taken N layer very small thickness? Because the light incident on the N layer, that light will pass to the or penetrate to the junction. That's why purposely taken very less area or less thickness of the N layer as compared to the P layer. Now we go for the constructional diagram of our yes, it is having an as usual, it is having an yes, this is nothing but your P layer. Consider it an N layer. This is a P layer. And important thing, as I said here, your P layer is here having an your junction, also having a depletion layer here. It is having the negative here. Consider like this. It contains a negative ions here. It contains a positive ions here. This is only what you know about the depletion layer. And here you can connect in, especially on the top of the N side. You can use the metal contacts, especially you can use the silver finger type electrodes. You can use it on the top of N side. We are using a metal finger electrodes. In the top side of the N side, we are using a metal finger electrodes, or some they given about the silver finger electrodes, because silver is a good conductor of electricity. You can use metal finger electrodes, or we are using about the silver finger electrodes on the top surface of the here. It is having this is nothing but your metal contacts. Or I said about yes, this is nothing but the metal contact. Or I said about you can deposit a metal finger electrode on the top of the N surface. On the top of the N surface, we can deposit a metal finger electrodes or a silver finger electrodes on the top side of the N side, top of the N side. And also it contains a glass window, as you know, because the light will incident on the junction. This is nothing but a glass window. And here metal contacts, and this is also having below also having a metal contact. Below also having a metal contact. What is the metal contact? This also has metal contact. This is the back side and front side, the metal contact. And look here, also the important thing, you can connect the here. You can connect an load resistance here, RL. This is nothing but negative, this is nothing but positive. Look here, once again repeat the construction. Yes, first you take a P layer of thickness, as I said, about 300 micrometer. The P layer having the thickness 300 micrometer. On the P layer, you can grow the N-type layer by the method of diffusion. On the P layer, you can grow the N-type semiconductor, N-type layer on the basis of diffusion process. and N layer having the right here the N layer, this N is having the 0.3 micrometer and P layer having the 300 micrometer. Then actually what happens, as the light rays are incident here, as in our photodiode, no doubt, in the your solar cell, whenever the light incident on the solar cell, or whenever the light is striking on the solar cell, or whenever the light is incidenting on the solar cell, or whenever the rays, so solar radiation really incident on the your solar cell, especially you are using the, in general you are using silicon, but ideally you can use the gallium arsenide. Gallium arsenide, because we want the energy curve should be 1. The Eg should be 1.5 electron volts, and here also this energy, your h nu, is greater than the Eg. No doubt, you are applying the incident ray, you are applying the light rays, that light rays energy should be more than the Eg. No doubt, here it's Planck constant, this frequency, this should be more than the Eg. Then what happens? Actually, you are studying the solar cell in the 3 ways. You can understand the process of generating EMF, process of generating EMF, or you can study the solar cell in 3 processes. One is called generation, and the next one is nothing but generation, separation, and collection. You study about the it means you can understand the working of solar cell in the 3 processes: generation, separation, and collection. Look here, what is generation, what is separation, and what is the collection. Look here, as in your photodiode, as the light incident on the your junction, PN junction, what happens? Or I said, you apply the energy, the photon of energy, that should be more than the Eg. Then what happens? This incident light, because you are using the N layer very less thickness, because that incident ray will move towards the junction or move towards the depletion layer. That's why I am taking the N layer very small as compared to the P layer. This incident light will enter into the junction. As you know, we are applying the very high intensity of light. This light, what happens? In the depression layer are the atoms. They are neutral atoms. It means you are having the silicon atoms in the depression layer. If you are applying the, as you said in the photodiode, this is the silicon atom. It having the 4 valence electron in the proton list. If you are applying the high light energy, then because it high light energy, this electron will come outside. This electron nothing but the is called free electron. And this atom that acts as a hole. Or as you are already you know about, whenever without breaking the current, but you are getting the current. It means because of light energy, high intensity light energy, we can break the current one, and we will get here electrons and holes will be generated. First, generation. How you can generate the electron holes? The generation of electron holes, nothing but because of the high intensity light falling on the junction, a PN junction. Then what happens? Because of the high intensity light incident on the junction, here in the depression layer, they will generate the electron hole pair will be generated. The electron and hole pair will be generated. What is called generation? No doubt, in the generation we can generate the electron hole pairs. That is because of the incident light. You are incidenting the high intensity of light. Because of high intensity light, they will break the current bond in the depression layer. They can generate, for example, here, the electrons and hole will be generated. And as we know, the electron and hole, they are generated in pairs. And important thing, what is separation? What is separation? Now you know about generation. Generation is about how we can generate the electron holes. No doubt in the depression layer you are not having any, it is immobile carriers. It is nothing but depleted charge carriers. You are not having any electron, you are not having holes. But as the incident light, as the light incident on the junction, they will break the valence bond. In the depression layer, having the electron hole be phase generated. The electron hole phase generated in the depression layer. This generated electron hole, the brings separation. What is separation? Because of the high electric field, as you know here I have the high electric field. Because of the electric field here. Because of this electric field, what happens? These holes will move towards the p side and electrons move towards the n side. Because of the electric field in the depression layer. Because of the electric field in the depression layer, these holes they move towards the p side and electrons they move towards the n side. Why there is separation of the electron holes? Because of the high electric field. Because of the electric field or because of your barrier potential in the junction, the holes they move towards the p side, electron they move to the n side. That is nothing but separation. Separation is nothing but separating electron holes. How actually they want to recombine, but because of this electric field, the holes they move towards the p side, electron they move towards the n side. This separation of the electron hole, that is because of the electric field in the depression. What about collection? What about collection? No doubt that means that shows their meaning. Collection. These electrons will be collected. This is the metal contact. You are using a metal electrode here. This metal electrode will be collected. All the electrons to the metal electrode. No doubt here electrons are there. This electron will be collected with the metal contact. Or you are using a metal electrode. As I said, you are in silver electrode, finger type electrodes. The silver finger type electrodes will be connected with the electrons. This electron will be connected with this metal contact or your metal electrode. The metal electrode will be connected with all electrons. In the same way, this holes is also connected with the same back side of your metal contact. Or this also is again metal coated. It is also metal coating. This metal coating will be absorbed by your holes. This metal coated will be absorbed by the electrons in the hole, and below you are having your holes will be connected by the back side of your metal contact. And as you know, here there are more electrons are connected by the top side of the electrode. That's why having the negative charge, more number of negative charge here. And here there are the more number of positive charge here. It means they will create a voltage. That voltage is nothing but the photo voltage. What is photo voltage? You can write here photo voltage. You can write photo voltage. What is photo voltage? Why it is called photo voltage? This you are generating the voltage. That is because of the incident in the photon of energy. This you get the here voltage, negative and positive voltage. Because here you are having more number of electrons, they are having negative charge, and here are the more number of holes, they are having the positive charge. They will create a potential difference here. Or they will create some electrode here. Here negative electrode, positive electrode. And important thing, it is something called photo voltage. They will create a voltage here. That voltage is nothing but the photo voltage. Why it is called photo voltage? The voltage because of the incident in the light of the photon. The voltage is because of the photons. Photon is nothing but that is nothing but incident light of the sun. That is about the photo voltage. Once again I repeat, very simple, important thing, you are not applying any biasing. Keep it in mind, you are not applying any biasing. And the important thing, whenever you are studying the working of solar cell by the three processes, generation, separation and collection. And look here, what is the generation? As the light rays are incidentting on the, as you are having the finger type electrodes here, and also you are having the glass window, and as I said, L layer very less thickness because this incident ray will move towards the penetrate to the junction, and also you said about P layer is as compared to L layer is very thick. It means the incident light will move towards the junction or depression layer, and because of high intensity of light rays, what happens in the depression layer? they will break the current bonds and they will generate the electron hole pairs. Generation of electron hole pairs, that is because of the incidental light. Because high intensity light, you are falling on the junction, that light move towards your depression layer, and in the depression layer are atoms, that because of the high intensity of the light waves that are in the atom, you can break the covalent bond and electron hole pairs generated, and that is the generation. Generation is generating electron hole pairs, that is because of the incidental light. Then it was separation. No doubt here electron holes are generated, but they will be separated. Why? That is because of the electric field in the depression layer. The electric field in the depression layer will be separate electron holes. Actually, I want to recombine. Because of the electric field of the depression layer, the electron will be separated. Then last collection. The separated electrons and holes, because of the electric field, the electron move towards N side, the hole move towards B side. And here there are holes. That holes will be connected with the metallic contact in the below side. Here electrons are there, that will be connected by the above you are having then metallic contact, or you are having an as I said towards silver finger electrode. This will be connected with the electrons, and because that what happens in the above you are having the negative charge and below you are having the positive charge, or you can generate the photovoltaic and can generate the EMF by the help of solar energy. That is called a solar cell. It is called, why it is called solar cell? Because you can generate the EMF by the help of the solar energy. It means you are generating the voltage here. The voltage is what? Electrical energy. You are generating electrical energy, that is because of the photons, or because of the light energy. It means, now we go for the last about the VI characteristics. We go for the VI characteristics. We go for the VI characteristics. Also you can say about the, this is, as you know, this is a cell. This is the cell. In this cell, whenever the light incident on the cell, that is nothing but solar cell. You can say about light also. That's cell, the symbol of solar cell. Then you go for the VI characteristics. Last you go for the VI characteristics. Okay, here the VI characteristics. What are the VI characteristics of solar cell? They are very simple. As usual, you are studying them by the graph, by the help of graph. You are studying what is the effect of current and voltage. As usual, your voltage. This is your current. I. The important thing. As compared to your photodiode or light emitting diode, you are studying the VI characteristics in the fourth quadrant. As you have studied in the LED, you are studying about in the first quadrant, because that conducts in the clockwise. And you are studying the photodiode, that you are drawing the graph in the third quadrant, because that is reverse bias. But you are studying the solar cell in the fourth quadrant. Why? Because you are not applying any biasing. You are not applying any biasing. And important thing, actually, why you are drawing the graph or VI characteristic in the fourth quadrant? Because your speciality of the solar cell, it is not drawing any current, but it supplies the current. It is not drawing any current, but it supplies the current. That's why you can go for the light here. It's called VOC. It's called ISC. Now you go for what is VOC and what is called ISC. Look here. Whenever, as we know already, VOC is nothing but open circuit voltage. VOC is nothing but open circuit voltage, and ISC is nothing but short circuit current. ISC is nothing but short circuit current. SC is nothing but short circuit. OC is nothing but open circuit. Open circuit, short circuit. ISC. And what is the open circuit? What is short circuit? No doubt. If you are not using any RL here, if you are not connecting the load, then here you have the some voltage occurs here. That is called, you are not connecting any RL, you are not having any load here, but you will get the voltage here. That is nothing but open circuit voltage. You are not connecting any load here, no doubt you are having the voltage here. That voltage maximum here. In the open circuit, you are having the maximum voltage. that you have written here VOC. You are not connecting any load here. You are having the negative charge, positive charge. They are having some voltage. This voltage is maximum. That is something called open circuit. Open circuit voltage. Here the voltage is maximum, but the current will be zero. You see the current will be zero because you are not applying any load here. And it is open circuit. How the current will go? You are not having any path for the moving up current. Here is totally open circuit. It means in the open circuit you are having the maximum voltage, but current will be zero. As we know, current will be zero. And what about the ISC? You connect it here. You make it short here. You connect the both ends. It means you are short circuited. Here what happens? No doubt you are having the maximum current, but voltage will be zero. You see the voltage will be zero, but you are having maximum current. In the short circuit you are having the maximum current, but voltage will be zero. ISC is nothing but the short circuit. Short circuit is nothing but you are connecting directly positive to negative. And here what happens? You are having the maximum current. In short circuit, as we know, the R will be zero because you have the maximum current, and here the voltage will be zero. The voltage will be zero here. This is about the short circuit. And in between here, what happens? If we connect the load here, RL, then the current go through the current will go through the solar cell. This is about the VI current set of your solar cell. Important thing, the VOC, ISC. VOC is nothing but open circuit voltage. ISC is nothing but short circuit current. Because if you are not connecting anything in between, it is called open circuit. In that time, the voltage will be maximum. If you connect the short circuit, join the positive and negative terminals, then you get maximum current and voltage will be zero. This is about the VI current set of your solar cell. Right? And lastly about applications. Maybe you have covered everything. Applications. You go for the applications. In applications, as we know, nowadays we are giving more importance to the solar energy because in solar energy, our space vehicles, especially your satellites, they require the energy. They require some voltage. They require some energy. That energy given by the solar cell. No doubt you are in the space vehicles, your satellites or any vehicles. They are moving in the space. They want some energy. That energy given by the solar cell. Or you are using some calculators, or you are using some wrist watches. They are also telling about the solar energy. You are using some watches, or you use some calculators. They only depends on the solar energy. If by the help of solar energy, can construct your as I said, watches or calculators, they are based on the solar energy. Especially you are using in your power electronics. You are using solar energy in the power electronics. This is about the important about the solar cell. The important thing you are using especially ideally you are using about the gallium arsenide or the energy capacity near about the 1.5 electron volt. That type of semiconductor you are using to construct your solar cell. This is about the importance of solar cell. Now we look at last about the digital electronics. Digital electronics. Digital electronics. Actually, you know, in the electronics, you have done the two branches in electronics. One is digital electronics, another called the analog electronics. Another called the analog electronics. Analog electronics. I am not going in detail because it is not technical. What is the difference analog and digital? In digital electronics, you are studying about the digital signal. You are studying about analog signal. What is analog signal? Nothing but it is called continuous signal. Analog signal nothing but continuous signal. Current and voltages, they will be moving continuously. But in digital, nothing but you are studying about the digital signal. That signal is not continuous. You are having only two states. It is having only two states. That digital electronics, they will obey they will work on the basis of binary codes. They are working on the principle of binary codes. It means in analog electronics, your signal, it may current or voltage, that will be continuous. But in digital electronics, they are signal and continuous. They are using only two states. They are having only two states, or they are using only binary numbers, 0 and 1. In the digital, they are using only binary numbers. This is about in brief about digital and analog electronics. No doubt, we will go for the in digital electronics. We are studying about the nowadays. It is more importance of digital electronics. It may be a digital computer, or it may be digital diary, digital watch, digital camera. So many things are digital because they are having a very compact in size, lightweight. They are very fast, and they will take very small space. These are the lightweight. These are the advantages about digital electronics. I will go for the most important thing about logic gates. Logic gates. In digital electronics, we study about the logic gates. What is logic gates? Look here, the logic gates are called basic building block of digital electronics. The logic gates are called basic building block of digital electronics. The logic gates are called basic building block of your digital electronics. Also, in logic gate, no doubt, in logic gate, it has many inputs, but only one output. That is about the definition of logic gate. No doubt, logic gate, it is a digital electronics device, and the logic gate, they will they will make the logical decisions, or they will follow the Boolean algebra. They will follow the Boolean algebra. The logic gates are nothing but this comes under the digital electronics. These are the basic building of digital electronics. And the logic gate, it has many inputs, output only one. And the logic gates, they will make the logical decisions. They will make the logical decisions, and also they will working on the principle of Boolean algebra. The logic gates, they are working on the principle of Boolean algebra. Right? And we will go further. We are studying about nearly about the 5 types of logic gates. We are studying about the 5 types of logic gates. One is called your basic gates and universal gates. We are studying about the types of logic gates. Types of logic gates. One is about the basic gate, and the second one is about universal gates. Universal gates. We go for in detail about what are basic gates and what are universal gates. Now we go for first we go for the basic gates. What are basic gates? Look here, you are studying about the 3 important basic gates. One is about basic gates. First one is about AND gate, and the second one is about OR gate, and third one is about the NOT gate. Let us go for first we go for AND gate. What is AND gate? Look here, this is the symbol of AND gate. AND gate. This is the symbol of AND gate. The symbol of AND gate. No doubt. It is having 2 inputs, A and B inputs. I just said here already, there is a Y output. It is nothing but A dot B. I will go for this is the symbol of AND gate and truth table. What is the truth table? Here in the truth table, you have A, B inputs and Y. Go to get output. Here, as usual, 0, yes, 0, 1, 1, 0, 1, 0, 0, 0, 1, 1, 0, 1. Look here, what is truth table? The truth table, nothing but is a table that indicates the relation between the input and output. That shows the related input and output. The truth table is a table that indicates the relation between input and output, that relates the input and output. It is the relation between the input and output. The truth table is a relation between the input and output, or it shows what is the possibility of the output for the different inputs. What is the possibility of output for the different types of inputs. This is the truth table. The important thing in the AND, the most important AND, what is AND? It is also used as a multiplier. In the digital logic, you are using the AND gate is nothing but a multiplier. Because you see here, 0 into 0, 0, 0 into 1, yes, 0, 1 into 0, 0, 1 into 1, 1. It is used as a multiplier in digital electrons. The AND gate is also called as the multiplier in the digital electrons. Because, and what is the main function of AND gate? The important thing, if the both inputs are 1, 1, then the output is 1. If the both inputs 1, 1, let us got 1. On you say, can say 1, or you can say I also. Or you can say this 1 nothing but 5 volts and 0 nothing but low, or nothing but 0 volts. Consider 1 or high. Both inputs high, output is high. Or both input 1, 1, then the output is high. This is about the importance of AND gate. It is having two inputs and output is only one. That is about A dot B. And what is the importance of AND gate? When the both inputs are 1, 1, the output is 1 only. Other than 1, it is 0 only. The inputs are 1, 1, or both input high, then the output is high, the remaining term is low. This is about the importance of AND gate. And important is so important about it's called basic gate. Why these are the basic gate? Because by using these gates you can construct any other device in the digital electronics. This is called basic gate. It is one type of AND gate. AND gate nothing but it is nothing but it is a basic gate. It is used as a multiplier. It is having two inputs and output is A dot B. And important thing, one nothing but high or 1 or 5 volts is also called as on, and another is also called as on. It is also called as off. That also on and off also we consider sometime. And this is about the symbol about the AND gate. Then go for another one about OR. We go for the OR gate. OR gate. This is the symbol of OR gate. And here also I have two inputs A, B, but what output is A plus B. Output is A plus B. Here you can write here everything is same. Only I can change the output, that is A plus B. Look here. Then, what is the important of OR gate? No doubt it is a type of basic gate. Important thing here also inputs are 2, output is 1. But it is used as an adder. It is used as a, in the logic it is used as an adder. Because as you know, the 0 plus 0 is 0. 0 plus 1 is 0, sorry. In the OR gate, important thing about in OR gate, it is used as a adder. 0 plus 0 is 0, 0 plus 1, 1, 1 plus 0, 1, but 1 plus 1 it is 1. Why it is 1? Because actually the 1 plus 1 is 2 only, but a 2 is not a decimal number. It is a, sorry, it is not a binary number. How we can write 2? That is 1 0. 0 carry as 1. In binary, we can write 2 as, it is in decimal 2. In binary, we can write 1 0. 0 carry as 1. You can write here 1 plus 1 not of 2 only, but how we can write 2? 0 1. 0 carry as 1. This is about the important of OR gate. The important thing OR gate. What is the main function of OR gate? Thing is that when the both inputs are 0, then only 0, otherwise 1. OR gate important thing. What is the main function of OR gate? When both inputs are 0 0, then only output is 0, remaining is high only. What is important OR gate? When both inputs are low, output is low. Or when both inputs are 0 0, output is low, remaining time is 1 only. This is about the importance of OR gate. This symbol of OR gate, this is the truth table of OR gate. Important thing 0 0 0, remaining times 1 only. This is about the importance of the OR gate. Next we go for last about the NOT gate. It is also called as inverter. It is also called as inverter. It is very simple. Only one input, one output. It is one input, one output. We are not having any. Yes, A give off. For example, table is very simple because it has only one input, A bar. This only one two possibilities, 0, 1, 1, 0. It is also called as complement. It is also called as complement. It means the input output are in the opposite. 1 means 0, 0 means 1. Input 1, input 0, output is 1. And input is 1, output is 0. It is nothing but inverter. It is also complement or not gate. Here is only one input or output. Both are complement to each other. Both are reverse opposite to each other. This is about simple about not gate. Then we go last about the universal gate. We go for last about the universal gate. We go for the last about the universal gate. Universal gates. There are only two universal gates, NAND and NOR gate. Why these are called universal gates? Because by using the NAND gate, you can construct the AND gate, you can construct OR gate, or you can construct NOR gate. By using only NAND, you can construct the other DC gates or anything in the digital electronics. You can construct any logic circuits by using NAND. Also, by using NOR, also you can construct the AND or NOT. Or can construct any logic circuits by using NOR gate. That's why it's called universal gates. By using only one NAND gate, that acts as the AND gate, that acts as the OR gate, that acts as the NOT gate. By using only one NOR gate, that acts as the AND gate, that acts as the OR gate, that acts as the NOT gate. This is about the importance of universal gates. Why these are universal gates? Because by using only one NAND gate, we can construct AND gate, OR gate, NOT gate, XOR gate, XNOR gate. Like that, you can do it anything in the digital electronics. You can construct any logic circuits by using NAND and NOR. Now we go for what is called NAND gate. What is called NAND gate? Here NAND is also called as a complement of AND gate, or you can write NAND is nothing but AND plus NOT. AND plus NOT. That is nothing but NAND. AND plus NOT, that is equal to NAND, or you can write also here. This is your AND. This AND connect a NAND NOT gate to this. This is AND plus NOT. That is nothing but NAND. And here the symbol of NAND is nothing but we are having bubble in the output. It is similar to the AND, but we are having a bubble. That bubble is because of the NOT. A, B, this is Y is equal to A dot B bar. Bar because of the NOT gate. Okay, this is about the importance of the NAND gate. The important thing NAND gate, you can consider NAND gate here. This is nothing but A dot B bar. It means you can write here 0, 0, 0, 1, 1, 1. And as you can remember, here is your AND gate 0, 0, 0, 1. This make it complement of this. Here the important thing, the complement of AND gate. Nothing but this is AND gate. Make it complement. Sorry. Complement of this nothing but 1, 1, 1, 0. This is nothing but complement of AND gate. Yes, this is nothing but the NAND gate. What is NAND gate? The important thing NAND gate, not have only inputs and only one output. The important thing in the NAND gate, the important thing in the NAND gate is about the here. The important it is reverse. This is AND. You can write here AND. This is AND. Or you can write A dot B. You take the complement of this. 0 complement 1, 0 complement 1, 0 complement 1, and 1 complement 0. It means what is the importance of NAND gate? When both inputs are 1, then only output is 0. Remaining time is 1 only. In NAND gate, important thing NAND gate, when both inputs are 1, then only output is 0. Remaining times 1 only. The important thing on AND gate, both can write here dot. Otherwise NAND gate, otherwise AND gate. The dot indicates this NOT gate. AND plus NOT, this NAND. Important thing NAND gate, when both inputs are 1 1, output is 0. Remaining times output is 1 only. In AND gate, when both inputs are 1 1, output is 0. Remaining times 1 only. Or when both inputs are high, output is low. Remaining times high only. This is about the simple way of the symbol and table of the NAND gate. Last to go for NOR gate. Go for NOR gate. Go for NOR gate. No doubt. Is NOR nothing but OR plus NOT. OR plus NOT. That is nothing but NOR. Or you can write, you know the OR gate. This OR gate can write in NOT gate. This is OR plus NOT. That is NOR. AB. A plus B. Here A plus B bar. And as usual, you can draw the symbol. Important thing, arrange the bubble. As usual, A, B input and Y equal to A plus B bar. Here also you can write here A plus B bar. Right here A plus B bar. And important thing, first if you are in calculation, write your OR gate 0 0 1 1 1. Now what I said, the non-analytical complement of OR gate. What is NOR gate? It is a universal gate. It also 2 inputs, 1 output. And important thing, about the 2 inputs, 1 output. And important thing, NOR nothing but OR plus NOT. OR plus NOT, that is NOR. And important thing, it is also called as complement of OR gate, because here you know the OR gate 0 0 1 1, but if we get complement of this, it becomes 1 0 0 0. This is about the complement of your OR gate. And important thing in the NOR gate is about whenever the 2 inputs are 0 0, then only output is 1. Remaining times your outputs are 0 only. Keep it in mind. The inputs are 0 0, then only output is 1. The remaining time is 0 only. This is about the importance of your NOR gate. Once I repeat, in NOR gate, if both inputs are 0 0, output is 1. Or if both inputs are low, output is high. Remaining time is low or 0. This is about the importance of your NOR gate. Maybe you have covered all the gates. The important thing in the overall, you are completing about the semiconductor electronics. No doubt you are discussing some starting from the energy band diagram, how we can classify the conductors, semiconductors and insulators. Then you studied about the types of semiconductor, entrance, extrinsic. Also studied about the types of external semiconductor, P-type or N-type. Then you studied about the formation of P-N junction. It is nothing but the diode, P-N junction diode, how it works, forward bias, how it works, reverse bias. And then you studied about the EI characteristic. Then you studied about the applications of diode, that is your rectifier. It is what half-wave rectifier, full-wave rectifier. They are so important questions for IMAS. Half-wave rectifier, full-wave rectifier. Then you studied about lastly about the special type of diodes. It may be your photodiode, or it may be your light emitting diode, or it may be your yes. Today we discuss about solar. And finally go for the digital electronics. In digital electronics, studying about the logic gates. Logic gate nothing but they make the logical decisions, or they are basically building blocks of digital electronics. And in logic gate, there are many inputs, output is 1, and they will use the principle of Boolean algebra. And you are studying about the 5 types of gates. 3 are called basic gates: AND gate, OR gate, NOT gate. AND nothing but is non multiplication. In AND gate, when both input are 1 1, output is 1 only. remaining time is 0 only. OR gate, the thing is OR gate is nothing but adder. If both the input are 0, 0, then the output is 0, remaining time it is 1 only. That is about your OR gate. And finally, it is very simple about OR gate. One input output, they are always opposite to each other or complement each other. That is about NOT gate. Finally, about NAND gate and OR gate are the unit circuits, because by using NAND gate you can construct other gates. Also by using NOR gate you can construct other gates. That is called unit circuits. And what is NAND nothing but it is complement of AND, and what is NOR nothing but it is complement of OR. This is about today's class, and maybe you are completing the semiconductor electronics. Thank you.